Okay, so to demonstrate these various forms of basic collision detection, what I've done is I've created a very simple demo program that will be available on the class website for you, but if you want to recreate it yourself because you're just watching this video online, you're more than welcome to. This does use the game engine that I have created, the Java game engine, so you may have to track that down as well. But in any case, what I've done is I've created a few constants that represent the type of collision tests I'm going to be doing, and these also are going to represent the fact that I'm going to be able to move certain shapes around to cause collisions. So I'm either going to be doing just point collision using the none in terms of I'm not moving any shapes, I'm just moving the pointer around. Rectangle collision, where I'm going to move a rectangle around, and circle, where I'm going to move a circle around. I've set up a few fonts to display different messages. This message font is going to be used to display whether there's a collision or not, and UI font describes to the user how to use the program itself. And the string is just going to be what message is going to be displayed when there is a collision. So obviously if there isn't a collision, they're just going to be displaying nothing. And then I'm just defining a few shapes here. So I have two basic rectangles which are located on the screen, and I have two circles that are defined by a center point and a radius, as you can see here. So that's the basic setup. There's not a whole lot else involved here. Inside the update code, first thing I do is I give the user the option to switch between the type of collision tests they're going to be doing, rectangle, circle, or pointer. And then once they've had that option, then it's going to, depending on which one is currently selected, it's going to move one of the shapes to the location of the mouse. So if rectangle is selected, it's going to move rectangle 1 to the location of the mouse. If circle is selected, it's going to move circle 1 to the location of the mouse, just to keep things going. And then finally, we do collision tests. So if I'm doing a rectangle, if I'm currently moving rectangles, I want to do rectangle collision. So I have box-to-box collision. This is not one of the ones we discussed in the previous video, but it is one that's coming up. I just threw it in here just so you could see it in the demo as well. And the code for it is below. Then I did circle collision detection to see whether two circles are colliding. And this just returns a true or a false. If it's true, we display the message circle, circle, collision. And then finally, down here, if we're not doing rectangle or circle collision, we must be doing point collision. So I test the point against all rectangles and against all circles. If any one of those return true, then I display the appropriate message. So that's it for the update. So we're checking input types, we're checking movement, and then we're checking collision. And then finally, draw. Draw is just very straightforward. Draw the two rectangles, draw the two circles, and then draw our text. So this is our collision message, and these are our two UI instructions. Nothing there. So let's get down to the actual collision tests. Point to box. This just follows the algorithm we did. Does the point exist between the left and the right wall, and is it between the top and the bottom wall? If so, return true. Point to circle. Now I've done the shortcut for both of these, so I've said if the distance, I calculate the distance squared, which means I'm not going to be comparing it directly against the radius, I have to square the radius. So if the distance squared is less than or equal to the radius squared, we have a collision. Similarly speaking, for the circle to circle, I do the exact same thing, but it's the distance between the two center points, and I have to check it against the sum of the two radii, not just the one radii. If that distance is less than or equal to, then we have a collision. Then the box-to-box collision, which you're going to see in future videos. Basically, to briefly describe it, there's so many possible scenarios where two rectangles can be colliding that we don't want to test for that. It's very costly. So the easiest way to test for a rectangle-to-rectangle collision is to check for a no collision. What I mean by that is that there's 4 possibilities where it's physically impossible for there to be a collision. So if I have two rectangles, if the right wall of rectangle 1 is too far to the left of the left wall of rectangle 2, it's physically impossible for them to touch. We do a similar test for top, right, top, left, and bottom. And if any one of those evaluate to true, where then it is physically impossible for there to be a collision, so we return false, no possible collision. However, if they all fail, if all impossible options fail, by process of elimination, we must have a collision, so we return true. So it's a lot cheaper to check for a no collision than it is to check for a collision. So those are our possible scenarios, and if I run the program, you'll see here it says click the screen to start. So now I can actually start adding input. And if I mouse over a box, I get point to box collision, point to box collision, point to circle collision, and no matter, as long as I'm in there, and point to circle collision over here. So let's hit the R key, and now this rectangle is moving with my mouse, according to the top left corner. We're just going to kind of nudge it over and pop. And as long as we're touching, we have collision. Great. So now let's switch over to circle. So now the circle is centered on my mouse and doesn't affect the rectangles. I don't have that test in here. As long as it's touching that edge or even fully inside, we have a collision. And then if I hit the escape key, it goes back to the mouse pointer. So that's the whole demo, and hopefully that'll give you a good grasp of how to use it and you'll be able to apply it. In the future videos, I'm going to quickly discuss other forms of collision detection that are available to you.